In this problem, we are told that a dart leaves the barrel of a gun at a speed of v. And so that's actually going to be our final velocity. We know that before it is initiated, it's just going to be sitting there in the blowgun. And so initial velocity is 0. The distance is traveled is simply going to be the length of the barrel. And we want to solve for time. And we're told that we want time is equal to 2L over V. So I know that this thing is accelerating. I want distance and time in there. So I'm going to start with one of my kinematic equations. So I'm going to start with this equation. Distance is equal to initial velocity times time. Excuse me, we're going to use I for initial. There we go. Initial velocity times time plus 1/2 acceleration times time squared. Initial velocity is 0, and so that's going to cancel out. And so I can put in my variables. I have length is equal to 1/2 acceleration t squared. But if we look right here, there is no acceleration in this problem. So I'm going to look at one of my other kinematic equations and do a little substitution. So I'm going to have final velocity is equal to initial velocity plus acceleration times time. And so why did I use this one? Because the other one, this other equation, this one's kind of hard looking. And then if we plug this in, we're going to get 2 L's, and there may be a square in there. And then we have some squares right here. And so I just felt that this equation, which is also the definition of acceleration, would be easier. So let's look at it in its normal form. So acceleration, remember, is the change in velocity divided by time. These are really the same equation, just rearranged for different variables. And so my initial velocity, again, is 0. And so I have acceleration is equal to that final velocity, which is just v, divided by time. And so I'm going to plug that in for my acceleration. And so we see that this time and one of those are going to cancel out. And it's looking like we're on the right track here. All right, multiply both sides by 2 because we're trying to get time by itself. And then divide both sides by our velocity. And now we've arrived at the equation that we were asked to derive, 2L over V. And so that's the first part, A. Now B wants us to prove that time is 0.19 for the information given. So we're told the length is going to be 1.4 and velocity is going to be 15. And so if we plug that in, we get a large number. It's going to be 0.1, not large, excuse me, a lot of decimal places, 0.186, blah, 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 blah. But we need two significant figures because we were given significant figures. So you're going to get 0.19 seconds, and that proves that we are correct.